So in today's video we are going to be overclocking the NerdQaxe. This is a follow-on from the video previously, so yesterday, and in that video we hooked up both of these NerdQaxes to this power supply that you see here, so you can go watch that if you want to see us wiring that in. But the main purpose of that video was mainly to allow for better voltage regulation on the actual both of them and free up another power slot for plugging in, so we could run two off of one plug instead of two for two plugs. And it also allows us to overclock a little bit more. So this power supply is 350 watts, which means that each of these can probably share 150 watts each. But today we're just going to be going for pure overclocks on one of them, and that's going to be this one here. So this is the regular NerdQaxe. I think I still have a 10% code if you want to go get one on the power mining shop, so you can get 10% off that, but they might all be sold out, so you're going to have to wait quite a while to get one. But we are going to be overclocking that one because it has that copper heatsink which we upgraded, which means it's probably got a better heating solution. You can kind of see it if we zoom in here. I don't know if you can see that properly, but this one on the edge here is 54 degrees and this one is 40 degrees. So there's a big difference between both of them in that regard, because if this one's at 40 degrees and this one's at 50, that basically means that that heatsink is doing quite a lot of work in terms of the cooling, which means in theory we should be able to cool it quicker and overclock it a little bit more. We also going to use this wire because that one that's plugged into there is a 18 AWG, so 18 on the wire gauge, and this one is 16. So the lower it is, the better it's going to hold the current or move the current through. So we're going to unplug both of these and then plug that wire right there into that one right there. And that should hopefully give us a better ability to overclock. And one of the main reasons why we got this is because we can change the voltage. So we want to supply 12 volts for the whole time that we're overclocking. If we see it dropping down, we could actually just turn that a little bit and give it up to 12 volts again. So if you're not familiar with power supplies or not familiar with electronics, I'm not an electrician, but the way that it works is obviously as you overclock, you are going to lose the voltage. It's going to drop off very quickly. With a power supply like this or a power supply like that, you can change the voltage. So currently it might be at 12, but if we overclock it, the voltage that is actually supplied into there is probably going to drop down. So we can keep increasing it until the voltage in the actual system comes up to 12 again, because that's probably where it's going to function the best, and we don't really want to put stress on the miners. I'd rather the stress go on the power supply than the miners. So as I said, we're going to unplug both of them and then plug that wire into that one, and I think we'll just move on to the computer. We're going to go with the first overclocks that we hit. So we did an overclocking video just with the regular power supply, like this type of power supply, and I think we got up to 6 terahash, but I know, or I've seen at least, results that people have got these with better cooling solutions obviously, but they've got them up to around 10 terahash. I don't think we're ever going to hit that, just because you'd probably need 2 more fans on there, but we can at least try push it to 7 or 8 terahash on one of these. So let's head over to the computer and we'll get into how we're going to overclock this and benchmark it. Okay, so before we get into that, you can kind of see the setup that we're working with. I didn't put it on the stand just because I realized I don't have the spacers and I'd have to take them off the other one, and I can't really be bothered to do that right now. So you can see our setup. We have 2 fans. One of the fans is blowing kind of across half the heatsink and the voltage regulators, and then that fan is obviously cooling the heatsink. So we have the fan set at 80%, and then we're just going to overclock from there. We don't have automatic fan control, so we're just going to see and monitor. Let's bring it over to the computer and check what we were last working with on the overclocks and then get it set up. So here we have our last overclock. I'll just bring it into cinema mode. It shows here our core voltage is 1170 and our frequency was 725. So that's what we're going to actually start it on. We do need to do some editing to the file for a second. So we have the file open here. I believe we need to edit with idle because we need to change just a couple of things in there. First off, if it actually loads up. So first thing that we need to edit is going to be the max power. So we can allow this to run probably till, I want to say 170 if possible. And then I think everything else should stay the same. Max allowed voltage. Let's just put this up to 400 or 1400. And then max allowed frequency, let's put this to 1200 just in case. Max VR temperature 75. Let's just bump this up to 84, let's just say. And I think that should be it. So max temp is 65, that's fine. Everything else looks fine. File and save that, and then exit out. And then we want to come over and open up our benchmarking tool. So we search here, CMD, and run that as an administrator. And we just want to CD into the bitaxe hash rate benchmarking. So paste that in there, click enter. I do have a video on this if you really want to learn how to benchmark it. I think if you just search in how to find the best overclocks for your bitaxe, this video should come up. And then we go into here, take this, paste that in there, and then we need the IP address, which we have here. So 192.168.493. And then we need to set a frequency. So frequency, as we said, we're going to start it on the previous maximum that we got to. So that's going to be 725. And then the voltage, we're going to start it at the maximum we got to, which was 1170. So 1170. Click enter, and that should start to run, as you can see here, or hopefully it does run. It says there, this tool will stress test your bitaxe, applying settings there, and we can see that has happened. So what we're going to do is we're going to monitor the input voltage as time goes on and adjust it on the power supply until basically we get down to 12. So it will start dropping off. As you can see in this video, the input voltage was dropping off to 11125, so nearly 11,000 volts or 11 volts instead of the 12 volts that the system actually needs. So we're going to monitor that, and then we're going to adjust it as time goes on. And we'll come back when we've kind of finished off the benchmarking results. I think it's probably going to clock out maybe at 7,500 gigahash or 7.5 terahash, but I'll show you all the results once we're done with that. There's not really anything else that I can cover. The ASIC temperature and the VR temperature, they're probably going to be very cold until it starts ramping up a little bit. But as I said, the fan speed is stuck at 80%, so I'm kind of countering the fan speed already, which basically means that I know it's going to ramp up to 80%, but I want to see when that 80% is actually clocking out in terms of the temperatures for the VR and the ASIC. So as I said in the start of the video, I've seen pictures and videos of these NerdQaxe++s getting up to 11 terahash. I don't think we're ever going to get up to that because we need a way better cooling solution. But for now, I think that heatsink and that fan is going to do very well. Obviously, we'll let this run. So you can see here, this is probably how we're going to monitor the voltage, just looking at this. And then over time, once it resets to the next setting, we'll up the voltage on the power supply and try keep it at 12 volts. Obviously, we don't want to up it too much because then we can potentially break the system. So let's let this run, and we'll come back when we have the full results, and that's probably going to be the maximum overclocks that we can hit on these NerdQaxes that we have. And then we're probably going to run them at about 80% of those overclocks for the foreseeable future, just because we have the amount of power supply to actually do that. And we'll also cover the efficiencies if we get good efficiencies as well. So we'll come back after this is all done, or at least it stops itself. So after running our overclock testing that you can see here, we've had a bunch of problems with it because there's a lot of information that I actually didn't know. So with the NerdQaxe++ at least, they are protected, and we'll kind of get into that. But the highest that we ever got up to was probably around 6,700. That's where it tapped out. And I don't think it can go any further than that, because you see you have weird results here where it just caps out at this. So you can see the terahash is just the exact same. Nothing changes on here. The temperature changes, but the gigahash doesn't actually change. And then you go down and it comes down to 3.8 gigahash or 3.8 terahash. And then I was wondering why this was, so I did a bunch of other tests and kept testing it and testing it. The one that we capped out at was 6.5 terahash. But this test had been going on, so I reset it and tried to do it again and again and again. So you can see we got up to 6.3. That is kind of a steady hash rate. I think the highest is around 6.3 terahash that you see there. So I obviously asked around, and I just posted this on X, and I got the answer to my question. So the post was, if we go up here, anyone tell me why I can never push this past 6.7 terahash? No matter what I do, it'll never go past that. So this was maybe 12 hours ago, so overnight testing. And then somebody said a capped ASIC frequency setting, I think 750 is the max. It doesn't matter what the settings are within the OS that reflect it, it won't go past this. A must-have safety feature. Some have unlocked this, but it's not really advisable. So there is a possibility to unlock it to obviously get better overclocks. But I think 750 is the max. And then a little bit more information on this. A few guys in OBM have pushed the NerdQaxe past the stock limits. You need custom firmware to go higher than 750 megahertz. So I did not know this, and it wasn't really specified that you couldn't overclock these. And then they also said, or another person said, this isn't a OC unless you changed a few parts, including the barrel connector, which is rated for 8 amps. So 8 amps times by the 12 volts would give us 96 watts. So realistically, pushing it past that, it's not rated to do any of that, without taking in the fact that the efficiency simply drops, which is nonsense. We haven't really seen the efficiency drop too much though. And then that says, correct, the connector is only rated for 8 amps, but stays just below that. It's still not safe. And then there's a bunch of people posting their overclocks. The ASICs are not capped, but the voltage regulators at some point, they are running at 100% capacity. So there'll be nothing you can do. Running this board over the standard specs is a fire hazard anyway, which, you know, when you're overclocking is always kind of a fire hazard, but I think we're just hitting about 6.5 right there. So that's at 100 watts, and I just want to mention the ASIC frequency is 750 at 1170. So I don't even think that that's very high necessarily in terms of the frequency and the voltage. And then another reply to this is, I think some manufacturers are using a higher rating on the barrel jack, so I don't actually know what ours is. I haven't looked into the actual barrel jack to see if it's 6 points or something like that, or 5 pointed ones. So they use 10 amps, and then 10 times by the 12 volts gives us 120 watts with a 5-point connector, as opposed to an 8A 3-point, but it's safe to assume all are 8A. But then it does go to say below that, even that we just covered, the ASICs are not capped, but the voltage regulators at some point are running at 100% capacity, so there's nothing you can do. So I'm really conflicted on if we actually have one of these. We can check it out right now. Maybe those who sell the so-called OC version, but money-wise, I don't think that they do. Frankly, I don't know anybody yet who's selling the 10A connector. So I'm just going to assume, without taking the 10A connector off, that basically nobody is using the 10A connector. And then there's just another post there. They hold that 150 core up to a higher frequency than most bitaxes. A few can do 700, others require 1175, 1200. But this frequency is pretty good at 750 at 1170, and that puts our hash rate at around 6 to 6.5. We did get it up to 6,900 steady for a little bit. You can push the chip past its absolute max it was written for, regardless of cooling, etc. So you can't push it past. But I mean, I've seen bitaxe gammas that have a maximum, let's just say, of 2 terahash. Like, we've even pushed the bitaxe gamma to 2 terahash, and if there's 4 of those chips under the NerdQaxe, then you would assume that the maximum would be 8 terahash. So that's mainly why you can't overclock these to a certain extent. And I did not know this, and I don't think it was really specified necessarily in terms of the maximum OC that you can do with these machines, but I think the maximum, at least with our setup, is going to be around 6.5 terahash. So we nearly hit up into 7 terahash, but there was some kind of threads out there that I've seen where people have pushed it, and that was probably with the custom OC and the different connector for the power supply. So overall, I think still you can get them pretty high in terms of the 6.5 range from the 5.5 range, or the 5 range. So it normally stays at 5 terahash, but you can get it up to 6.5, so you can add an extra 1.5 terahash, and you can see we have 1 rejected. So I don't think it's unstable right now, but you guys can let me know in the comments. The VR temperature is very high on these, but the ASIC temperature seems to be kind of alright. It is getting a little too hot, but the fan is not working at 100% speed yet. This power is also not rated. I suppose if it's for 8 amps, we're about 4 watts over, if you look at that. So maybe we'll just dial it back, keep it at something like a 5.5 terahash, and then go from there and just keep both of them at 5.5 terahash, because there's no point overclocking it if we can't push it further and further and further. As I said, there is a cap on them, so until kind of the custom firmware or the barrel connectors, we could do a barrel connector change to get it to a 10 amps, but I don't think it would allow us to overclock that much more on both of these machines. So I think that's the end of the journey for overclocking the NerdQaxe++. There probably is going to be another video, actually, us overclocking the Zyber 8 at some point. So we are going to try and overclock that, but as I said, or as I've discovered, it requires a little bit more research into these miners, because I don't think that's well-known knowledge. Only people that are building them would actually know that. You know, the average person is probably not going to know how far you can actually push a miner. So same with the Zyber 8, we're going to have to do a lot more research on that to find the best overclocks. But if you enjoyed this video and the whole process and hope you learned something, make sure you like, subscribe, and I'll see you in the next one.